This is Unit 5, Lesson 2, Proving Triangles Congruent Using Side, 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 and Side Angle, Side. 3 diagrams here. What can you conclude from the diagram? Write congruent statements. The first one here has been done for you. So looking at problem A, 2 things are marked. Line segment AB is marked congruent to line segment DE. And then these 2 particular angles have been marked. Nothing else is marked. So we cannot assume that these triangles are congruent. Nothing can be done here. One thing to point out about the letters, please notice that with the angle measures and even the sides, they're going in the same order. A, C, B, and then D, F, E. So that the congruent marking is at the center and the letters are traveling in the same location, in the same order around the triangle. Over here at letter B, 2 things are marked. Angle Q is marked congruent to angle S. Those are the single markings. There's 2 other angles that are marked, and they're denoted with the 2 curves. We can't call it angle P because angle P could refer to the whole angle or either part of the angle. So whenever there's doubt as to what the angle could be called, use all 3 letters. So I'm going to do angle QPR. So I went from the single marking up to the double marking down to no markings. Single, double, none. So I'm going to make sure that the other angle goes the same way. Single, double, none. SRP. What else can be assumed? If you think about these 2 triangles, they're touching along this seam. If they each have the same seam, then these have to be congruent. And we mark it with an X. It's referred to as the reflexive property. And it's of congruence. Reflexive, reflection, it's the same thing. Basically, if 2 triangles share a side, then the sides are congruent. So using the reflexive property, we can assume that segment PR is the same as segment PR. So what do we have? We have an angle marked, an angle, and a side. Thinking about this other one, we have an angle, a double angle, and a side. So we can't make any statements yet about the triangles, but we can make congruent statements about their pieces. Lastly, this one's a little bit more complicated. A couple of things are marked. We have that angle M is congruent to angle S. Those are marked with a single. We have that segment TO is congruent to segment NV. And we can use this reflexive property to assume that since these 2 are the same section of the side, that they must be congruent. So I have that OV is now congruent to OV. So think about this in sides of a triangle. They both share this red portion at either end. So what happens is that the segments, that whole side of the triangle is congruent. So really, because of these, using the segment addition property, we can conclude that really the whole side length of this, I'm going to color this triangle in blue. Let's get all this other markings out of the way. That this triangle here in blue, that this red side, TV, is really congruent to, I'm going to mark this triangle in green, this black side right here, which is ON. Couple other things in this diagram. Think back a little bit to everyone's favorite unit. What do those little arrows mean? They mean that we have parallel lines. So if those lines are parallel, I'm going to redraw it over here. The transversal that's cutting those, this line right here. So what it's creating for both is these alternate interior angles are congruent. So they're over here. So it ends up being angle MOV is congruent to angle SBO. If lines are parallel, then alternate interior angles are congruent. So there is a lot that we can get out of here. And then something that I added, I don't remember if it was before or after I made the copies, was I added the official definition, should have been, there it is, of reflexive property. A quantity that is congruent to itself. And then here's an if-then statement, if you want to tack that on as well. Previously we learned in the very first unit, or the very first lesson, that you need every angle congruent and every side congruent. We discovered that we only talked about 4 of the shortcuts. There's really a 5th that I have to show you why it works. So we don't need we don't need every single angle and every single side. We need a combination of 3. The ones that we're going to deal with today are side, 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 which we constructed in class together, and side, angle, side that you constructed over the weekend. Side, side, side is a postulate, as is side, angle, side. They're accepted as fact. If 3 sides of one triangle are congruent to 3 sides of another triangle, then the triangles are congruent. We discussed in class that if you were given length GH, HF, and GF, the triangle that you create would have to be identical. The next one, side, angle, side, says that if you're given 2 side lengths, so a side length, and an included angle, meaning that this angle, the side lengths are made up of that angle. So we have a side, the angle, and the side. So it's in between them that those triangles will be congruent. So what does it mean to be included? Included, think in between, in the middle. Very often they're a part of what it is you're creating. Opposite is very often across the figure. So the side included by angle C is down here, and CDB, so this whole angle. Well, if you think about angle C extends, this angle out here extends, so what side is included? It is side CD. The angle that is included by segment AB and segment DB, what one's in the middle, what do they create? They create angle B. Angles that are opposite. So AD is this angle right here, or side length right here. So go across, well, angle B is across, and angle C is across. Side opposite BAD. So here's BAD. So the side that is across is segment BD. Side, side, side. What else do we need to prove by side, side, side? Well, we need the third side, which would have to be this one here, congruent to that one there. So we still need segment AE to be congruent to segment DE. Here's 2 triangles. What would we need for these to be proven by side, angle, side? We'd need a side, an included angle, and a side. Here is a side, check. Here's an angle, check. So I need the third side. Side, angle, I would need this side. So the next one, if we talk about side, angle, side. Well, I have a side, same thing over here. But what I don't have is the angle in between. So extend the side lengths, and the angle they create is this one here and that one there. So we would need angle C to be congruent to angle R. What else do we need to prove the triangle is congruent? We have two methods currently, side, 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 angle, side. Looking at this diagram, I can use the reflexive property to assume that AT is congruent to itself. So if we're going to use side, 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 we'd need the third side. If we're going to use side, angle, side, well, I have the sides. I would need the included angle. Side, side, so it's got to be the top one. Side, side, so it's the top one. Angle HAT would have to be congruent to angle CAT. And again, you can't just call it angle A because there are multiple angles at the top for angle A. Is there enough information to prove the two triangles congruent? If so, write the congruent statement and name the postulate. So for problem 20, I see a side, an angle, and a side, an angle, and a side, angle, side. For sake of time, please write your own congruent statement. Problem 21 looks to me like we have three sides, side, side, side. For problem 22, I have sides, but I'm either missing the third side or I'm missing the included angle. So this one is not possible, so there's no congruent statement that you could create here. 21, side, 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 so they're all marked. 24, I have a side marked congruent. They're both 2. This one gave me numbers instead of markings. And then the 6s, since they're butted up against each other, they share the segment in the middle, so I can assume that's congruent. Side, side, side. You'd be able to make a congruent statement. Lastly, for 25, I've got the double markings on each, the single markings on each, and I have an angle that's created from those that is in between. Side, angle, side, and make your congruent statements.